Hey, Airflow community. Airflow 3 is here and we are taking it on the road. Join the Astronomer Roadshow for an exclusive deep dive into the latest features, hands on demos, and expert insights, all in a city near you. We'll be in London in May, New York City in June, Sydney in July, San Francisco in July, and Chicago in August. Don't miss your chance to connect with the Airflow community and get the inside scoop on what's next. Register now. The link is in the show notes.
Hello everyone, welcome to the Data Flowcast. I'm your host, Mark Lamarty, and today I'm super excited because I'm joined by Gil Reich, data engineer for data science at Wix.com. How are you doing, Gil?
I'm doing well, thank you. And I'm very excited too. And congratulations on the release of Airflow 3. And,
All right.
you're a legend here at Wix because most of us learned how to program Airflow by being told, here, watch these Mark Lamberti videos. So thank you.
Thank you so much. Thank you so much, Gil. And indeed, as you said, Airflow 3.0 is out, so I recommend anybody to try it out. You will enjoy that new version. All right, so that episode is going to be amazing because basically you will learn how to create more maintainable, efficient, and testable Airflow implementations through framework development, as you will discover later. Gil Gil created a framework that I'm super interested by. And you will see some techniques and optimization strategies that significantly reduce execution time for your data pipelines and tasks. So that being said, Gil, can you tell us more about you actually? Like, what do you do at Wix.com today? And yeah, just a little bit of your background.
Okay, sure. I'm originally from New York. I'm living in Israel. I've been writing code professionally for almost 35 years, since probably before most of the listeners here were born. And I'm a data engineer for the wonderful data science team at Wix, where I basically create pipelines or manage help the data scientists and the data scientist users run their models and get their data.
That's amazing. Uh, just like for information, like how big is your team today?
How big is our team? Well, the data science and engineering team itself is I think 4 people now. The data science team is, I think we're about 50. The data engineering team is 100 and
Wow.
something. So it's a big company.
So I guess like you have many Airflow instances running, right?
Yes. I think we have many pipelines running.
Yeah, right. Okay, great. So I guess like I would like to start with this question for you. Like, when you joined Wix, you actually inherited from pretty complex Airflow code base. And what were your biggest lessons learned? When you had to basically to start with all of that code base. What were the lessons that you learned? And what advice would you give to a team starting to experience, like those kind of challenges when you inherit from a big code base like you had?
Okay, yeah. I think the biggest lesson I learned was it's very easy to create new Airflow DAGs by copying and pasting existing Airflow DAGs.
Okay.
It's easy, it's safe. In the short term, it's a brilliant idea. You're not going to break anything existing. You're copying code that worked for somebody else on something similar. So it all feels great. It's easy. It's a great way to get moving, but in the long term, it's a disaster. And
Okay.
that's the main thing I learned. You just can't do it. It's very tempting. And 6 months ago, my best advice for here would be, um, stop copying and pasting code, or at least if you're tempted to copy and paste, stop and think about it and make sure it's really what you want to do. And especially if there are already 2 or 3 or 4 versions of what you're copying and pasting, definitely stop and start again. Now the advice is even worse because the problem is worse because now I go to PyCharm, I type 2 words, and GitHub Copilot already gives me the next 20
Right.
lines, which is in some ways wonderful, and is in short term wonderful, and long term a disaster because it's just
Yeah.
more and more duplicate code. So I think you just really need to be on the lookout for duplicate and near duplicate code, and realize that it's going to hurt you in the long run. And you and your future self will and the people who inherit your code will thank you for taking control of it. And you can start small. Don't start. We didn't start with building a framework. We started with small refactoring. We took the worst problems and we created variables and functions and whatever, and then we kept going. And every small win led to inspired us to keep going. until we had a framework that we were really happy with.
Yeah, and actually that's very true. I mean, the interesting fact about your answer is that it is not related to Airflow. It's just related to programming in general, right? Like you just should avoid duplicating code as much as you can, because otherwise you're gonna end up with this massive code base with a lot of duplicates everywhere, and it's gonna be just a nightmare for you to to maintain that.
So I think for Airflow, it was more challenging for me because it's an orchestrator, because it's doing a lot of clever and intelligent things that were not always intuitive to me. I mean, it was the correct way to do them, but a lot of things were counterintuitive to me. It was always hard for me to remember
Yeah.
what gets evaluated in the operator, what has to be evaluated before, when things happen, when you can resolve variables. All these things were so confusing to me that it was just I couldn't resist the temptation of copying an exist working DAG.
Yeah, I mean, yeah, I did the same as well. Um, so I guess like one quick question for you because you mentioned a framework, and we're gonna circle back to that in a second. But first, you also said that you started with small optimizations before creating that framework. So can you maybe tell us a little bit more about that? Like what did you start doing before creating that framework?
Okay, so
To avoid
I'll
the
give you an
duplicates.
example of the most egregious problem that was in our code.
Okay.
Um, it was that so every day we all of our processes were creating these temporary tables.
Okay.
Okay, so every process creating temporary table, and so originally we appended the DS, the timestamp or the date stamp, the execution date to the table. And then we said, well, that's not enough because that's not unique because you may be running a backfill and a daily run in the same day. So you have to add the type. And then we said, that's not enough because sometimes you run twice on the same day. And what winds up happening is we actually had the same Jinja template um,
Mhm.
copied among like 30 different tables. So we had 30 different tables that were defined by constant, that was specific to that table, and then a Jinja template that started as one variable
Okay.
and just kept growing and growing and growing and growing. And then we said, that's not enough. We need to add the full timestamp with the dates and seconds. And we said that didn't work because that has a T in the middle or the formatting was wrong and it didn't create a proper table name. And so everything wound up being more and more until we had this enormously ugly and difficult, ridiculous, which is in some ways was worse because we weren't consistent always with single quotes and double quotes. So even searches and replaces became hard. So it just became insane. And I hadn't, again, because Jinja templates and what gets evaluated when was so confusing to me. So I didn't understand until somebody told me, you can just make a variable for that. So we just made a variable for what we're appending to the table names, one variable, updated in one place, and everything else uses that variable. So that's something that's super obvious when you realize you can do it. And it just made the code so much more manageable.
Yeah, I mean, to your point, I mean, there are like some like some basic features I would say in Airflow that you should definitely leverage, because that will help you a lot to make your DAGs cleaner, your tasks cleaner, and variables is a good example of that. Okay, that's definitely an interesting example. I guess like maybe that wasn't enough to avoid duplicating your code. And I know that this is because we had a discussion previously, obviously, but and I know that this is when you decided to create a framework to actually help you combating like duplicate code. Can you tell us more about that? Like, could you walk us through the structure of this library and how it helps maintain clean and reusable code in Airflow?
Okay, sure. So again, so when we started, we had like three different files creating three very similar orchestrators and seven different files creating very similar or similar framework or similar structured DAGs and a bunch of different copies of an append to history function, all these things. So we created a framework that would organize all these things. In the center of the framework is a class called DSDAG. That DS
Okay.
because it's created by us, the data science team. That's the central class that creates the tags and their tasks. We have a DAG manager class that manages the DAG. So there's one per project. My favorite class is the doc creator class that we realized at some point that if we're automatically creating the DAGs, then we might as well create the documentation. as we're doing it.
Right.
Yeah, so which is great, and that's actually the main reason why even on small, because the framework is great for complex projects, and the reason main reason I also use it for small projects is to get the automated documentation,
Okay.
which is fun. And then there are a
Yeah.
few other classes, but those are the big ones. And I'll just give an example of what the DSDAG class does. Is in many of our pipelines have three different tasks for trigger model, wait for model run to complete, and validate model results. So
Okay.
that's a common pattern. So
Okay.
now we have one function inside DSDAG that's called create run model tasks, and that creates a Python operator to asynchronously trigger a model. It creates a Python sensor to see when that model finishes, and it creates another Python operator to run a validation code. So it basically what was a lot of code duplicated in a lot of places became one very simple function call.
Okay. So that function call creates the three tasks that you just told about.
Yeah, yeah. So
Okay, I see. I see. And you actually mentioned models. Can you just just to make sure that what we are talking about here, like what do you mean by models? Do you mean machine learning models? Do you mean like DBT? Like what do you mean?
machine learning models.
Oh,
Machine
okay,
learning.
okay. So
Most of the pipelines we run are running machine learning models in their center.
okay, okay, okay. And so you have a bunch of functions that you can call to generate uh, tasks that you will automatically add to your DAGs. Is that right?
Yes, yes, yes.
Okay. And so like how does it work exactly? Like can you tell us more a little bit about the implementation here? Do you use a configuration file? Do you just import the function in your DAG right away and then you call the function and that's it? Like can you tell us more about the implementation here?
Sure. So basically we separated the code into sort of three parts. Or the first division is we took these shared whatever code could be shared, whatever functions could be shared, we put in the framework. And
Okay.
then within each project, we separated between the code and the configuration. So the
Okay.
config file, the Python dictionaries have all the things like table names and settings and things like that. And then the code for each project actually it imports the library. It imports
Okay.
library and creates code on the library. So for example, you create your DSDAG manager object and you pass it the configuration, the
Okay.
config object, and then you do DAG manager dot create DAG and give it the name of the DAG. And then you take these DAGs and you you call the create tasks functions on each DAG. So for example, then so DAG manager equals DSDAG manager, passing config file. Then
Uh-huh.
DAG is DAG manager dot create DAG with the name of the DAG, and then DAG dot create tasks, create run model tasks. So basically there's three lines of code that really creates already a DAG with the run, wait, and validate tasks to it.
Okay, okay, this is amazing. So and that configuration file, is it like a YAML file or is it
No, it's a
JSON
Python dictionary. It's a Python
Python
dictionary.
dictionary? Okay, okay. And so I guess like you have a bunch of Python dictionaries corresponding to your configurations stored somewhere, and then you like is
Yeah,
that
so for each project there's one configuration object or one configuration file for each
okay,
project.
okay, okay,
So for example, is the main project that triggered this whole project, that inspired this whole project, it was it's an an orchestrator with 7 internal DAGs. So wound up with one configuration which has sections for each internal DAG, and then the DAG manager knows how to pull out each part for each internal DAG.
okay. Well, this is super interesting. Because like usually, I mean, in my previous episodes, most of the time I came across people that were generating DAGs using like a Python script, right? Like they just run a Python script and that generates the corresponding code. But this is not exactly what you do, right? Like
So
you actually have a Python function that just return. I mean, when I say just, that returns tasks, and basically like those tasks are the some like common patterns that you have in your data pipelines, and so you are calling functions that return tasks. You are not calling a function that generates a DAG. It's just it's actually different than what I used to see.
yeah, I started in that direction. and my teammates talked me out of it, and they talked me into this direction, which I'm very happy about, because this
Okay.
way it's understandable. It's not one super function that creates all these DAGs out of anything.
Right.
Well, it's no. There's a program that has to go in and decide what task groups he wants to create, and I'm much happier this way. And I find the code much easier to understand and debug, etc., and maintain.
Yeah, and I mean that's definitely an interesting take. Did you create that framework for avoiding duplicating code, or did you actually create that framework to have a sense of standardization? So even like data scientists, for example, can create DAGs as well, or maybe both. Like, did you create that framework for both reasons?
Yeah, yeah. My hope was that the entire data engineering team would start
Okay.
to just use this framework, 'cause I thought it just made things much easier, especially within the data science group, because we're using so many of the same types of pipelines that
Right.
this, I hoped, would make all the DAG writing much easier.
And so, what about when you need to, like when you need to add a new task that is not in your framework? Like, how does it work? Do you add that task to your framework, or just do you? How does
Yeah,
it
so
work?
good question. So right now the complication is that
Okay.
we created a package out of the framework. And what
Okay.
that means is that it's not that simple to just add a function to it and use it, because there winds up
Okay.
being all sorts of deployment issues,
Yeah.
and there might be all sorts of things. So what I do for right now is I either make the code locally and also change the framework so that first I have it locally, that is within the project, and which could also be, sometimes I can derive from the DSDAG, or derive from the package and add to a derived class of the package, and then when I get a chance, update the framework and then use that instead. What we
I see.
may also do is just bring it all back, is get rid of the deploy package and just put the framework back as a separate directory inside of our code base, and this way I can just go and update that more easily and use that.
Okay, that's good. And I guess like just maybe one last question regarding the framework. What would you say are the pros and cons of using that solution?
The main pros are that it's much easier for me. Once you get used to it, it's easier to write the DAGs with. Especially, it's easier to especially the complex DAGs I've been writing. It's much easier to write and maintain them. It's a much easier to have one place for all the code that's shared. It's self documenting, which is a great thing, and it's not Gen AI documentation. It's not approximate documentation, and it's not documentation that can be outdated. It's documentation that gets regenerated dynamically each time the DAG is generated. So the documentation is always accurate and always up to date, which is
Wait,
fantastic.
how do you do that? Because I almost missed that part. So how do you do that?
Okay. So when the DAG creator is creating the DAG and adding
Yeah.
tasks, it also adds to the MD file
Uh-huh.
that's sitting in the same directory. Then we load it through the as you know, you can add set the documentation on the DAG.
Yeah.
So basically, as we're writing the DAG, we write the documentation, and then we have special code that also understands. So we have tops and bottom sections that will say these are all the assets that are modified by this DAG, and my favorite part, these are all the tasks of the DAG. Now, sometimes, ideally, there are a few lines that are actually manually written. So, for example, I have the essence
Uh-huh.
of each DAG. You write that once, and then that comes in, it gets pasted while you're creating the DAG. Um, but all the DAGs are in. And my favorite part is that it has all the sources and the links to the source. So, for example, if the if the new task is a Python operator that runs a certain script, so at the bottom of the DAG documentation, it will say the create table task is run by this script linked to its GitHub file in this directory. It'll say this, and this task is run by this SQL, and here's the source of that SQL. So it's the same again, because the same way it's able to create the tasks, it just takes all that information and throws it into a doc file.
Damn, this is cool.
It's very good. It's really cool. I really like it.
Yeah.
And the second thing another pro of why I like using the framework is it has a mechanism to override the local configuration. So for example, we run local airflow. That is, we run an airflow in a dev Dockerized environment on our laptops. and that's how we can test our code and play with it and things like that. And so we have a whole local mechanism there that will it will change the add prefixes to the table names or change table names so that we're not overriding the real data, and it will add settings like row limit, so only run on 10,000 lines instead of millions of lines, so we can more easily test and develop locally. So the framework has all those things built in, and those are the pros of using the framework. And again, another pros, anytime you add something, like for example, we could trigger GitHub workflow, just
Okay.
something got needed for one project,
Okay.
and a couple other people needed it too, and there was some duplicate code, so I just added it to the framework. And now it's a single function call. Will trigger and wait for a GitHub workflow, and everything's built in there, and it knows what variables to ask for if it can't just get it from the config. So those are all the pros. The con, so two cons. One is if the framework is in a separate package that's deployed separately, then modifying it is a bit of a headache because because you have to wait for the deployment, and you need this change now, and you can't wait for the deployment. So that's a headache. And another problem is that the framework is sort of in my native language. It works for me. To me, it's the most obvious thing in the
Okay.
but I find that and I know the same thing. When I try to learn somebody else's code, it was obvious to them.
Yeah.
It's not obvious to me. And the same way, that also means that Google and ChatGPT and all these things are familiar with the normal way to do it. They're not familiar with my framework's way of doing it. So
Right.
those are their costs to going non-standard, to doing things differently than everybody else is doing.
Right.
Especially in a world where ChatGPT and Google give you so much information. So
Right.
those are the main cons, and those are serious cons. And if people wonder, but Gil, if you're on vacation or you leave the company or you get hit by a bus or whatever, you may think this is the easiest way to maintain your code, but somebody who doesn't understand, who's not in your mind, it's not the easiest way for them to maintain your code, and that's a real question.
Yeah, right. That's very true. Actually, well, I hope that you will never be hit by a bus.
Thank
But to your point, actually, I mean, whenever you come with a a new solution, I think like the hardest part, honestly, is to get the adoption of that new tool that you expect, right? Because ultimately, we all have our own habits, our own way of doing things, and whenever you have like another solution that is meant to standardize everything, I mean, there are always some people that struggle with that. But again, I just love your solution. I like, just to summarize and let me know if I'm right here, but basically your data pipeline at Wix looks like a bunch of function calls, right? And those function calls at the end generate a DAG with some tasks. And again, those tasks are actually common patterns that you will find in many DAGs at Wix. And that's why they are behind functions. So you don't have to rewrite those tasks again and again. I love that. I love that solution. I think again, it's very different than what we used to hear here. About generating your DAG using a template, for example. So this is a really cool solution. I need to ask: is it open source?
I shared the code. I shared the
Okay.
code. I'm not standing behind the code. I'm not I provided the code so people can look at it and see it and play with it.
What's the name of the framework again?
It's a DSDAG framework.
Okay.
DSDAG. So yeah, you can. I can send you a link to it, or I don't know if you have show notes or whatever. But
Yeah, and by the way, like for people that really wonder, because I think you actually made a talk about. I mean, you did a
yeah,
talk about that in
yeah,
the
it was.
previous Airflow Summit. So feel free to check Gil talk out. You will learn more about this framework specifically, and it's worth the time. Okay, so moving on to the next topic that I would like to touch on, because as you said, you are running machine learning models at Wix.com. So what are the specific challenges of ML orchestration with Airflow that you had? Do you have any like challenges that you had when you actually started to orchestrate machine learning models with Airflow?
So I think the main thing that the machine learning team has been doing differently than some of the other teams here is, in addition to all the scheduled Airflow DAGs, we also have a lot of on-demand Airflow DAGs. We
Okay.
found that we have a lot of tasks that our data scientists are running, and we provide them a UI, and we basically, those UIs, and whether they know it or care about it or not, on the back end, basically, it's those UIs are triggering Airflow DAGs. So we basically have these Airflow DAGs that are providing that are wrapped inside services, and the DAGs up communicate back statuses and error messages or whatever to those services. So that's, I think, the main thing that the machine learning task team is doing differently. So, for example, data scientist wants to train a model or run a stress test or create a data set or do all sorts of things, or even build a test set for a Gen AI project. We have all these things,
Okay.
functions that data scientists are using, and and really what it is an Airflow DAG triggered in the background that's communicating back with the service. That's the main
Okay.
difference. That the main challenge that the ML data engineering team took on that we think has been unique to us, I think, or different than most others are doing.
Just to clarify here, when you said the ML engineering team, ML engineering team is different than the data science team.
Okay, so the data science is the data science team includes data scientists, data engineers, and other engineers. So here I'm referring to, so the data scientists are using these tools created by both engineering, it's created together by the engineering and the data engineering teams inside data science.
Okay. Okay, great. So can you tell us more about, maybe you had some, did you have actually to make some optimizations, for your tasks because of those machine learning models that you are orchestrating on Airflow? Is there any optimizations that you have on top of your mind that you had to do?
Yeah. So one optimization that we did was, again, one of our most complicated pipelines, and pipeline that drew me into the framework. Our customers wanted our results in the morning, and we were delivering them in the late afternoon.
Okay.
And the reason that was happening, again, because we're running seven DAGs sequentially.
Uh-huh.
So each DAG was waiting for the upstream DAG to finish, and that took a long time. We had
Okay.
a sensor on each DAG, and when that finished, we moved on. What we realized was that the each internal DAG did some post processing. That is, it had the output ready, so the
Okay.
pipeline could really continue, and then it continued on some of its own tasks, storing the results in different tables and doing all sorts of things that the downstream DAGs didn't really need to wait for. So what we were
Okay.
able to do is the Airflow DAG external task sensor. If you don't send it a task ID, it waits for the DAG, but you can also give it a task ID, and then it just waits for that task. So we created, so now every internal DAG, it creates, once it finishes with its output, it runs this empty operator of output ready. And now our
Okay.
sensor tasks wait for that. And that cut down the pipeline by hours. So
By
it's
hours? Wow.
by hours. Yeah. So it was great. It was great.
Yeah, that's a huge improvement.
Yeah, it was a huge improvement. And it's the kind of thing, it didn't need the framework and the refactorings or whatever, except that it did, because when you can't maintain your code and you have 7 copies of everything, then
Right.
you don't even think in these directions, because who wants to make a change like that and debug it, maintain it in 7 different places, right? First, you need control of your code, and then you can do smart things. So as long as your code is out of control, you can't optimize it, and you can't extend
Yeah.
it, and you can't maintain it.
Well, that is a very good advice. Okay, just start by understanding your code and making sure that it is not a big mess, so you can actually focus on optimizing your tasks. How critical are the data pipelines that you run today with Airflow?
They're critical. I mean,
Okay.
our data science team is depending on it. Our data science team's customers are depending on them. Yeah,
Okay.
they're important.
So I guess, like, do you have any testing strategies in place to ensure that your tasks work as expected, that you don't have any bugs or something like that? Like, do you have any strategies like
Sure.
that? Okay.
Sure. We have really two primary things that we're doing. One is we have automated testing that
Okay.
we create the DAG, and then we load the DAG back in from the DAG bag and automatically check that the DAG and the task and the values that we meant it to create actually got created. So that's one level automated testing. And the second type of testing that we do is, as I said, we have local airflow. We have airflow running in Dockerized environments on our own machines. And as I said, we have a local config mechanism that knows to change table names so we're not messing with real data, and knows how to run on a more limited data set than on the full data set. And so we're able to just run that. So if it passes, so for code to go live, it has to pass the automated tests that
Okay.
in theory show that the DAGs, that the DAGs and the tests and values are what they expect it to be. And also that in practice, it runs properly and successfully. So we
Okay.
do both those tests before anything goes live.
Do you have a staging environment?
The staging environment is our local Airflow. It's
Oh,
the
okay.
Dockerized environment, local computers.
I see. I see. I guess like one last question regarding testing. Did you find any? Because this is actually a very complex topic, right? Like testing your DAGs in Airflow is not easy. So I guess like, did you find any challenges regarding testing your DAGs or tasks that you can think of, or not really?
The biggest challenge that we had that we had, I think the biggest challenge that I felt was that before I put together the framework, there was, at least for where I was working, there was no automated mechanism that said change table name so that when you run locally,
Oh,
you don't write anything. And there was no
yeah.
simple way
Right.
of running specific things or only in certain safe environments. And so that was the biggest challenge. What we did at the time was you'd have to comment things out and change names on your local version and hope that you didn't make a mistake and commit any of those to master and all these things. And so that was one of the impetuses of the framework, is to make that all safe working in the local environment for testing.
You know, the more you talk about that framework, the more I want to try it.
I'm very excited by it.
Well, Gil, one last question to you. Do you have any recommendations that you will make to data engineers that are listening to this episode today? Regarding Airflow and how they can maintain a better code base and so on. Like, do you have any recommendations?
The main recommendation is don't let things get out of control, and solve things early, and don't copy and paste, and or at least if you're copying and pasting, just try not to, and especially now with with Copilot and AI and whatever. I remember Joel Spolsky used to say that the problem with code is that it's easier to write than it is to read, and that's how code bases get out of control. Don't let your code base get out of control. And again, I think with AI, it's going to be an even bigger problem. So just don't let it get out of control.
What do you think about AI in general related to data engineering?
It's amazing. It's terrifying. It's powerful.
Okay. Yeah, I think it's all of that. Great. Well, thank you so much, Gil.
Thank you.
I think it was extremely interesting to to know about this framework that you built. Also, you touched on a very interesting optimization. So this is super interesting. Do you have any, like, actually, what is the best way for folks to get in touch with you if they have any questions?
The best way is probably LinkedIn, or you
Right.
can just email me at gilr@wix.com.
Awesome. Well, thank you again. Thank you so much for joining, Gil. And I'm looking forward to having another episode with you. Who knows? We'll see.
That would be great.
Thank you so much. Have a good day.
Thank you.
Take care.
Thank you.
Bye.